Okay. One thing I wanted to say before we move on to stack bars is about ordering levels. So this is, if you remember from our experience, this is a list. And so if you create a list and then in the factors function you add the name of that list, it's going to use the list order. Okay, so for stacked bars, this is with two categorical variables. We can display them on the same chart using the geom bar with position equals to stack. And so we see here we have an x and not a y variable, but it's called the fill variable is how you express that. So in this we can see how the distribution of heart attacks in fathers varies by heart attacks in the person who had them. So we can see the counts for each of those. So just for an example, so we know there was about 6,000 people who reported a heart attack. And so among those, about 600, among those about 150 maybe had a father who had a heart attack. Okay, so we can also put these beside one another using the option position equals dodge. And you can see now, I don't like this so much because you actually have to add these up to get the number of people who reported a self-heart attack, yes or no. We can show percentages or proportions on the y-axis by saying y equals percentage. So if you do that, the default is count. You get percent, which would be better labeled as proportion, which you can actually do. It's not exactly a percentage. So I think the way this works is just by expressing a y, you get a percentage or a proportion more accurately, whereas you get a count if you express no y in the labels. Okay, so now we're going to move on to box plots and violin plots, so where you have a continuous variable and a categorical variable. So box plots are a favorite to see the distribution. I really like them. So you can use that with the geom box plot. And we can plot the x as heart self. So by heart self, what is the distribution of life satisfaction? And we can see that here with the median in the middle of the box and the first and third quartiles at the edges of the box. And then you can see the mins and the maxes with the points. So a violin plot might be useful in some circumstances because it shows where the density of the data is. And so but I don't find these themselves to be super useful. We can see the max is 10 and the minimum is down here 1.3 or something, I think. For yes, and maybe a little higher for no, and then the mean or median is somewhere in the middle. So we can actually put the quartiles on here with draw quantiles. Actually, yeah, draw quantiles. So you can look at the help to see what options you have, but we can draw the first quartile, the 50th percentile, and then the third quartile. So we can see where those are. And I also actually added the mean and the median with the stat summary in red and in blue. And if you look at the summary, they should match the summary statistics. So you get the kind of the error function throws off that message. Let's see if we can get a better view of it. No, but the minimum is 1.33. The first quartile is 7.125. The median is 8. The mean is 7.73. The third quartile is 8.6, and then 10.10 is the max. So we can really make this fancy and not that useful plot by adding layers. So we can add a box plot, a violin plot, a scatter plot of the points for life satisfaction in each of those hard self categories, and see what we get. So now you can see the bulk of the points are in the white area with the biggest density. From the violin plot, you can see where it's widest, so that's what that's meant to show. You can see the median from the box plot, and the mins and the maxes. Okay, so let's move on to plotting a regression mean with error bars. So sometimes you might have a regression equation and you want to plot the means for each variable in the model that are the predicted means and their confidence intervals. So first we would need to perform a linear regression, and hopefully you're familiar with this. We'll do a lot of regressions later in the course, but we're going to do a linear regression using the LM function. Life satisfaction is the dependent variable, and then these on the right are all the independent or predictive variables, and the data is minus. And we're going to assign that to an object called mod. And then we can look at the model results with the summary function. And you see, you have seen things like this before. Get the output there. For each, you get the coefficient for each variable in the model. So it's saying the mean life satisfaction for males is 0.056 points lower than for females, if you remember how to interpret these coefficients. I don't remember what this does, but I don't think that's that useful. So we're going to ignore that. We're going to get the coefficients from the model and assign them to an object called myCoefs. So actually, we're going to get this from the summary of the formula, and we'll get the coefficients, and in brackets we want those in the second through fifth rows, and I think this is first and second column. Let's go back to the summary mod and dissect this. So we want these coefficients, so that's in the second through fifth rows, 2 through 5, and we also want the standard errors, which is the second part. So let's look. This code does that. Okay, and so now we're going to have a data set, and you can see what that looks like. So we get the coefficients with that code for age, sex, BMI, and self-heart disease, and then the standard errors for each of those coefficients. Okay. And we can use those standard errors and coefficients to calculate the confidence intervals using this code. There are other ways to do this. This is using a package called tidyverse. So this is going to add those values to that data set. So we have the lower confidence interval and the upper confidence interval. And we've labeled them here as LB and UB. So we're mutating that data set myCoefs to include these variables, the lower confidence interval and the upper confidence interval, calculated as follows. Okay, so now we can use that data set to make an error bar plot. The data is now my coefficients. We're going to plot the coefficient, and then we're going to give the x min, the LB, and the x max the upper bound, so the lower bound and upper bound, and y will equal the variable. So if you go, you can find all that in this data set. So we have the variable, we're going to plot the coefficients, and then we're going to say the x min and the x max are those lower bound and upper bound. And we use two geom functions for this, which is geom error bar h and geom point. So that's what you get. So we might not like the way this displays because they're kind of random in order of magnitude. So if we want to order them in order of magnitude, we can order the variable by the coefficients. So here we're going to say reorder the variable, and the negative coefficients is with the lowest coefficient first. You can change, there's another option added here, you can change the height of the error bars. I don't know what the default is, but you can look that up. And so now we have the lowest coefficient, which is this x1 at negative 0.05 up to self-heart disease, which is somewhere north of 0.3. And then their associated error bars. We can add a reference line, which is helpful in determining significance. Remember, for linear regression, if the confidence interval crosses 0, it's not significant at the 0.05 level, but if it doesn't cross 0, then it is. So I should mention here, we've actually assigned the whole ggplot to an object, so then you can do that because it gets easier rather than writing all the ggplot code again. So we can just add new layers to that object. So there we go, we have a red line showing that a few of these, 3 of the 4 are significant because their confidence intervals do not cross 1. And then we can add labels to the x-axis, which now it just says coefficient, and we can add a title to the plot. We could also add a y, we could remove that y or we are removing it by just specifying nothing. 2 quotes. And there we go. Okay, so if we want to edit text elements in the plot, including themes, titles, and legends, we can. ggplots are infinitely flexible, so that cannot teach you everything that you can do with these. You'll be learning as you do them, and you're like, I want to add this, and you will Google it and figure out how to add that. So here we're going to add a title and a subtitle and a caption, which is the source of data. And then we're going to annotate it with some text, which I'll show you. That'll add some extra text to the plot. Let's see what that is. And you can see all those where those annotations go with that particular code. We're plotting body mass at index against self-esteem for females and males. Okay. So we can also annotate with a rectangle. So this is annotating the plot with the text. If we wanted to add a rectangle, say we wanted to add a particular box, a particular set of data to call it out. These you can play around with the x min and x max and y min and y max. And other options in that annotate function to make it look like you want it to look like. But when we do that, I'll show you what that looks like. So now we see a rectangle calling out a particular set of points. And you might annotate some text to describe, on top of that, to describe what that particular set of points, why you're calling it out. There's other geom options for annotation that you can look at there. Okay, so suppose we don't want to have a legend, we can hide the legend, or suppose we wanted to put it on the bottom, we can use the theme function with the legend position specified as null if we don't want a legend, or bottom if we want it on the bottom. So here's the bottom one, and here's the no legend. So if we want to change the entire look of the plot, I actually use the black and white theme a lot, so it gets rid of that gray default background that I don't like. There you have a white background. I actually don't like the grid lines either, so we're going to learn how to get rid of that. So if you want to remove the minor grid lines, you want to remove the title of your legend, there's a bunch of different options that you can use. So you can keep adding themes to do this. So let's look at this. So if we want a black and white theme with changes, so in this one, we're getting rid of the minor lines with this theme with the option panel .grid.major equals element line color equals NA. And then in the second line, we're gonna change the line type and color of axis lines to dark blue and a solid line with the size of 1. We can remove the title with this legend.title equals element blank. We can center the title for the plot. There's just so many options that you can read through and change. But let's see how all of this looks. There's a lot. We're changing the angle. I'm not going to go through all this, but you can read all of it. There's so many different options within the theme to change different aspects. And see, I'm not sure this is a very pretty plot, but all of that code did that. And we can look at the original plot. Yeah, so I'm not sure what I like better. Okay, in the next video, we'll talk about playing with color.